was set at $200,000. Initially scheduled to ship in 2020, the vehicle has been repeatedly delayed. In July 2024, Musk said that the Roadster should enter production in 2025. Tesla Next Generation Vehicle. Main article, Tesla Next Generation Vehicle. The Tesla Next Generation Vehicle is an announced battery electric platform. It would become the third platform for the company. Vehicles based on this platform are not expected before 2025. In July 2024, Musk said that the vehicle should be available for delivery in the first half of 2025. Cybercab. Main article, Tesla Cybercab. The Tesla Cybercab, also known as the Robotaxi, is an upcoming two-passenger battery electric self-driving car under development by Tesla. The vehicle will be fully autonomously controlled, and has no steering wheel or pedals. A concept version of the Cybercab was unveiled in October 2024, with 20 prototypes providing short rides to attendees of the announcement event. Production is planned to commence sometime before 2027. Robovan. Main article, Tesla Robovan. The Tesla Robovan is an electric autonomous van planned for future development by Tesla. Announced in October 2024, the vehicle is being designed to carry up to 20 passengers. Discontinued Tesla Roadster. Main article, Tesla Roadster, first generation. The original Tesla Roadster was a two-seater sports car, evolved from the Lotus Elise chassis. It was produced from 2008 to 2012. The Roadster was the first highway-legal serial production electric car to use lithium-ion battery cells, and the first production all-electric car to travel more than 200 miles. 320 kilometers per charge. Connectivity services. Tesla cars come with standard connectivity, which provides navigation using a cellular connection. For a fee, Tesla offers a subscription to premium connectivity which adds live traffic and satellite maps to navigation, internet browsing, and media streaming. Vehicle servicing. Tesla's strategy is to service its vehicles first through remote diagnosis and repair. If it is not possible to resolve a problem remotely, a mobile technician is dispatched or customers are referred to a local Tesla-owned service center. As of October 2024, the company operates 1,306 retail stores, galleries, service, delivery and body shop locations globally. Tesla has said that it does not want to make a profit on vehicle servicing, which has traditionally been a large profit center for most auto dealerships. In 2016, Tesla recommended having any Tesla car inspected every 12,500 miles or once a year, whichever comes first. In early 2019, the manual was changed to say, "Your Tesla does not require annual maintenance and regular fluid changes, and instead it recommends periodic servicing of the brake fluid, air conditioning, tires and air filters." Charging services. Supercharger network. Main article, Tesla Supercharger. Supercharger is the branding used by Tesla for its high-voltage direct current fast chargers. The Supercharger network was introduced on the 24th of September, 2012, as the Tesla Model S entered production, with 6 sites in California and Nevada. As of July 2024, Tesla operates a network of 6,500 supercharger stations with nearly 60,000 connectors. The network is primarily deployed in 3 regions: Asia Pacific, over 2,650 stations, North America, over 2,550, and Europe, over 1,200. Since 2019, most superchargers deployed have been able to output as much as 250 kilowatt. As of January 2024, approximately 68% of chargers have V3 or V4 stalls capable of outputting this amount. Destination charging location network. Tesla also has a network of destination chargers, slower than superchargers and intended for locations where customers are expected to park and stay for several hours, such as hotels, restaurants, or shopping centers. Unlike the supercharger network, Tesla does not own the destination chargers. Instead, property owners set up the devices and set pricing. When the network first launched in 2014, Tesla provided free charging equipment and covered installation costs. One of the largest providers is hotel chain Hilton Worldwide, which in 2023 announced an agreement with Tesla to install 20,000 chargers across 2,000 of its properties in North America by 2025. Insurance services. Tesla has offered its own vehicle insurance in the United States since 2017 and has been acting as an independent insurance producer since 2021 as Tesla Insurance Services, Incorporated. It was introduced after the American Automobile Association, AAA, a major insurance carrier, raised rates for Tesla owners in June 2017 after a report concluded that the automaker's vehicles crashed more often and were pricier to repair than comparable vehicles. A study in 2018 based on data from the Insurance Institute for Highway Safety confirmed the findings. The company says that it uniquely understands its vehicles, technology and repair costs, and can eliminate traditional insurance carriers' additional charges. In states where allowed, the company uses individual vehicle data to offer personalized pricing that can increase or decrease in cost based on the prior month's driving safety score. As of January 2023, Tesla offers insurance in the U.S. states of Arizona, California, Colorado, Illinois, Maryland, Minnesota, Nevada, Ohio, Oregon, Texas, Utah and Virginia. The company also offers insurance for non-Tesla vehicles owned by Tesla owners. Energy products. Main article, Tesla Energy. Tesla subsidiary Tesla Energy develops, builds, sells and installs solar energy generation systems and battery energy storage products, as well as related products and services, to residential, commercial and industrial customers. The subsidiary was created by the merger of Tesla's existing battery energy storage products division with SolarCity, a solar energy company that Tesla acquired in 2016. In 2023, the company deployed 14.7 gigawatt-hours of battery energy storage products, an increase of 125% over 2022, but only deployed solar energy systems capable of generating 223 megawatts, a decrease of 36% over 2022. Tesla energy products include solar panels, built by other companies for Tesla, the Tesla Solar Roof, a solar shingle system, and the Tesla Solar Inverter. Storage products include the Powerwall, a home energy storage device, and the Megapark, a large-scale energy storage system. For large-scale customers, Tesla Energy operates an online platform which allows for automated, real-time power trading, demand forecasting and product control. In March 2021, the company said its online products were managing over 1.2 GWh of storage. For home customers, the company operates a virtual power company in Texas called Tesla Electric, which utilizes the company's online platforms to manage customers' Powerwall devices. discharging them into the grid to sell power when prices are high, earning money for customers. Business strategy. At the time of Tesla's founding in 2003, electric vehicles were costly. In 2006, Elon Musk stated that Tesla's strategy was to first produce high-price, low-volume vehicles, such as sports cars, for which customers are less sensitive to price. This would allow them to progressively bring down the cost of batteries, which in turn would allow them to offer cheaper and higher volume cars. Tesla's first vehicle, the Roadster, was low volume, fewer than 2,500 were produced, and priced at over $100,000. The next models, the Model S and Model X, are more affordable but still luxury vehicles. The Model 3 and the Model Y are priced still lower, and aimed at a higher volume market, selling over 100,000 vehicles each quarter. Tesla continuously updates the hardware of its cars rather than waiting for a new model year, unlike nearly every other car manufacturer. Unlike other automakers, Tesla does not rely on franchised dealerships to sell vehicles. Instead, the company directly sells vehicles through its website and a network of company-owned stores. The company is the first automaker in the United States to sell cars directly to consumers. Some jurisdictions, particularly in the United States, prohibit auto manufacturers from directly selling vehicles to consumers. In these areas, Tesla has locations that it calls galleries that the company says educate and inform customers about our products, but such locations do not actually transact in the sale of vehicles. In total, Tesla operates nearly 400 stores and galleries in more than 35 countries. These locations are typically located in retail shopping districts, inside shopping malls, or other high-traffic areas, instead of near other auto dealerships. Analysts describe Tesla as vertically integrated given how it develops many components in-house, such as batteries, motors, and software. The practice of vertical integration is rare in the automotive industry, where companies typically outsource 80% of components to suppliers and focus on engine manufacturing and final assembly. Tesla generally allows its competitors to license its technology, stating that it wants to help its competitors accelerate the world's use of sustainable energy. Licensing agreements include provisions whereby the recipient agrees not to file patent suits against Tesla, or to copy its designs directly. Tesla retains control of its other intellectual property, such as trademarks and trade secrets, to prevent direct copying of its technology. On the 15th of April, 2024, Tesla secured a deal with Tata Electronics to supply semiconductor chips, marking a significant step in Tesla's expansion into India's automotive market. On the 2nd of May, 2024, Tesla announced that it has abandoned its plan for next-generation gigacasting, a cutting-edge manufacturing technique. Initially aiming to revolutionize production and reduce costs, Tesla has now opted for its more proven method of casting vehicle underbodies in 3 pieces. This strategic shift reflects the company's focus on self-driving vehicles and adjusting to market challenges. Technology. Tesla is highly vertically integrated and develops many components in-house, such as batteries, motors, and software. Batteries. As of 2023, Tesla uses 4 different battery cell form factors: 18,650, 2,170, 4,680, and prismatic. Tesla purchases these batteries from 3 suppliers: CATL, LG Energy Solution, and Panasonic, the latter of which has co-located some of its battery production inside Tesla's Gigafactory Nevada. Tesla is also currently building out the capacity to produce its own batteries. Tesla batteries sit under the vehicle floor to save interior space. Tesla uses a multi-part aluminum and titanium protection system to protect the battery from road debris and forward/or vehicle crashes. Business analysis company Bloomberg NEF estimated Tesla's battery pack cost in 2021 at $112 per kilowatt-hour, versus an industry average of $132 per kilowatt-hour. 18,650. Tesla was the first automaker to use cylindrical, lithium-ion battery cells. When it built the first-generation Roadster, it used off-the-shelf 18650 type, 18 mm diameter, 65 mm height, cylindrical batteries that were already used for other consumer electronics. The cells provided an engineering challenge because each has a relatively low capacity, so thousands needed to be bundled together in a battery pack. Electrical and thermal management also proved to be a challenge, requiring liquid cooling and an intumescent fire prevention chemical. However, the decision turned out to be pragmatic because there was already a mature manufacturing process that could produce a high volume of the cells at a consistent quality. Although the 18650 type cells are the oldest technology, they are used in the Model S and X vehicles. Tesla sources these batteries with a nickel-cobalt-aluminum (NCA) cathode chemistry from Panasonic's factories in Japan. 2170. The next battery type to be used was the 2170 type, 21 mm diameter, 70 mm height, cylindrical cell. The larger size was optimized for electric cars, allowing for a higher capacity per cell and a lower number of cells per battery pack. The 2170 was introduced for the Model 3 and Y vehicles. For vehicles built at the Tesla Fremont factory, the company sources 2170 type batteries with a nickel-cobalt-aluminum cathode chemistry from Panasonic's production line at Gigafactory, Nevada. In January 2021, Panasonic had the capacity to produce 39 GWh per year of battery cells there. Tesla Energy also uses 2170 cells in its Powerwall home energy storage product. For vehicles made at Gigafactory Shanghai and Gigafactory Berlin, batteries with a nickel-cobalt-manganese (NMC) cathode chemistry are sourced from LG Energy Solutions factories in China. 4680. Tesla's latest cylindrical cell design is the 4680 type, 46 mm diameter, 80 mm height, introduced in 2021. The battery was developed in-house by Tesla and is physically 5 times bigger than the 2170 type, again allowing for a higher capacity per cell and a lower number of cells per battery pack. Currently, Tesla builds the 4680 cells itself and has not disclosed the cathode chemistry. The company has already opened production lines in Fremont, California, and plans to open lines inside Gigafactory Nevada and Gigafactory Texas. The 4680 cells are used in the Model Y and Cybertruck built at Gigafactory Texas. Prismatic. Tesla also uses prismatic, rectangular, cells in many entry-level Model 3 and Model Y vehicles. The prismatic cells are a lithium iron phosphate battery, LFP or LiFePO4, which is a less energy-dense type, but do not contain any nickel or cobalt, which makes it less expensive to produce. Tesla sources these batteries from CATL's factories in China. As of April 2022, nearly half of Tesla's vehicle production used prismatic cells. Tesla Energy also uses prismatic cells in its Megapark grid-scale energy storage product. Research. Tesla invests in lithium-ion battery research. In 2016, the company established a 5-year battery research and development partnership at Dalhousie University in Nova Scotia, Canada, with lead researcher Jeff Dahn. Tesla acquired Maxwell Technologies for over $200 million and sold in 2021. It also acquired Hyvar Systems. Tesla purchased several battery manufacturing patent applications from Spring Power International, a small Canadian battery company. Software. Tesla uses over-the-air updates to deliver updates to vehicles, adding features or fixing problems. This is enabled by tight integration between a few powerful onboard computers, compared to the way automakers had previously handled technology, by purchasing off-the-shelf electronic components for each subsystem that typically could not interface at the software level. The system also has allowed Tesla to control which features customers have access to. For example, for ease of assembly, all Model 3 vehicles were built with heated rear seats, but only customers who purchased a premium interior could turn them on. However, Tesla has allowed customers who didn't pay for a premium interior to purchase access to the heated rear seats. Tesla uses a similar software lock feature for enhanced autopilot and full self-driving features, even though all vehicles are equipped with the computers and cameras necessary to enable those features. Motors. Tesla makes two kinds of electric motors, an induction motor, and an internal permanent magnet, IPM, motor with synchronous reluctance motor, SynRM, characteristics. The older design is a 3-phase 4-pole alternating current induction motor, also called an asynchronous motor, with a copper rotor, which inspired the Tesla logo. These motors use electromagnetic induction, by varying magnetic field to produce torque. Induction motors are used as the rear motor in the Model S and Model X, as the front motor in the Model 3 and Model Y, and were used in the first-generation Roadster. Since the introduction of the Model 3 in 2017, Tesla has also been building IPM-SYNRM motors. These motors use an iron rotor, with slots cut into the metal where magnets are inserted in the internal core. As an IPM motor, it produces excellent starting torque. However, performance declines at high speeds due to counter-electromotive forces. For high-speed operation, Tesla engineers used iron's reluctance property, which allows it to spin in synchronization with the magnetic field of the stator if channels are cut into the core. These channels were also an ideal internal location for the permanent magnets to be mounted. The IPM-SYNRM motor is currently used as the rear motor in the Model 3 and Model Y, the front motor of 2019 onward versions of the Model S and X, and are expected to be used in the Tesla Semi. North American Charging Standard. Main article, North American Charging Standard. The North American Charging Standard, NACS, is an electric vehicle charging connector system developed by Tesla. It has been used on all North American market Tesla vehicles since 2012 and was opened for use to other manufacturers in 2022. Since then, nearly every other vehicle manufacturer has announced that starting from 2025, their electric vehicles sold in North America will be equipped with the NACS charge port. Several electric vehicles charging network operators and equipment manufacturers have also announced plans to add NACS connectors. Autopilot and full self-driving. This section is an excerpt from Tesla Autopilot.edit. Tesla Autopilot is an advanced driver assistance system, ADAS, developed by Tesla that amounts to partial vehicle automation, Level 2 automation, as defined by SAE International. Tesla provides base autopilot on all vehicles, which includes lane centering and traffic-aware cruise control. Owners may purchase or subscribe to full self-driving, FSD, which adds semi-autonomous navigation that responds to traffic lights and stop signs, lane change assistance, self-parking, and the ability to summon the car from a garage or parking spot. The company's stated intent is to offer fully autonomous driving, SAE Level 5, at a future time, acknowledging that technical and regulatory hurdles must be overcome to achieve this goal. The names autopilot and full self-driving are controversial, because vehicles remain at Level 2 automation and are therefore not fully self-driving and require active driver supervision. The company claims the features reduce accidents caused by driver negligence and fatigue from long-term driving. Collisions and deaths involving Tesla cars with autopilot engaged have drawn the attention of the press and government agencies. Industry observers and academics have criticized Tesla's decision to use untrained consumers to validate beta features as dangerous and irresponsible. Since 2013, Tesla CEO Elon Musk has repeatedly made inaccurate predictions for Tesla to achieve Level 5 autonomy within 1 to 3 years, most recently predicting the end of 2023. Glass. In November 2016, the company announced the Tesla Glass Technology Group. The group produced the roof glass for the Tesla Model 3. It also produces the glass used in the Tesla Solar Roof's solar shingles. Robotics. In preparation for Model 3 production, Tesla heavily invested in robotics and automation for vehicle assembly, and between 2015 and 2017, the company purchased several companies involved in automation and robotics including Compass Automation, Grumman Automation, Pabix Machine Company, and Riviera Tool and Die. Musk later said that the robotics slowed production of the vehicles. Subsequently, Tesla shifted towards using massive casting machines, known as gigapresses. These machines streamline production by creating large, single-piece underbodies, leading to reductions in production time, labor costs, factory footprint, and the number of welding robots. Critics note that reducing the number of components makes the vehicles harder or more expensive to repair after an accident. The company has been developing a humanoid robot called Optimus since 2022. Musk has stated that Optimus leverages the same core software powering Tesla's full self-driving technology and has suggested that it could be used within Tesla's factories to mitigate labor shortages through the automation of repetitive tasks. Facilities. See also, List of Tesla factories. The company operates 7 large factories and about a dozen smaller factories around the world. As of October 2024, the company also operates more than 1,300 retail stores, galleries, service, delivery and body shop locations globally. Primary facilities operated by Tesla. Open name City Country Employees Products Ref. 2010 Tesla Fremont Factory Fremont, California, United States. 22,000 Model S, Model X, Model 3, Model Y. 2016 Gigafactory Nevada, Story County, Nevada, United States. 7,000 batteries, Powerwall, Semi. 2017 Gigafactory New York, Buffalo, New York, United States. 1,500 solar roof, supercharger. 2019 Gigafactory Shanghai, Shanghai, China. 20,000 Model 3, Model Y, supercharger. 2022 Gigafactory Berlin, Grunheide, Germany. 10,000 Model Y. 2022 Gigafactory Texas, Austin, Texas, United States. 12,000 Model Y, Cybertruck. North America. Main articles: Tesla Fremont Factory, Gigafactory Nevada, Gigafactory New York, Gigafactory Texas, and Gigafactory Mexico. Tesla was founded in San Carlos, California in 2003. In 2008, the company opened its first production facility at a former Chevrolet dealership in Menlo Park, California. The original Roadster was assembled inside the service space until 2012 and used the company's showroom as a retail store. Another retail store was opened in Los Angeles the